with the Apollo program officially over, we move to the Space Shuttle program, and we're not focused on the moon anymore. We found out it wasn't really made out of cheese, so we're going to change our focus. And of course, the focus being a space station, and we need a taxi to the space station. And that's essentially what the Space Shuttle was a taxi, change out crew and cargo to our space stations. So this is the program patch for the shuttle program. Original sketch, so not too far off. Why can't you just fly an airplane into orbit? Well, essentially in space, there's not that air, and so your wings are useless. To get into orbit, a vehicle has to accelerate to about 17,000 miles per hour. And with enough speed, the spacecraft's going to move forward faster and the Earth's gravity pulls it down. But basically, the lift is not generated when we get into the space, as there's not that difference in pressure we've looked at earlier in the course. We're going to look at the specifications of the shuttle and the orbiter here. So the space plane is known as the orbiter. And the space plane can have the same flight mechanisms as an airplane: pitch, yaw, roll. So when we have the four components together, it's known as the space shuttle. When it's just the space plane, it's known as the orbiter. Although, as mentioned in class several times before, it's like Kleenex and tissue. People will call the orbiter the space shuttle when they do mean to say orbiter. The ET, external tank or main tank, and that's in your Alpha Mix appendix, as well as the SRB, the solid rocket boosters. These two images, or these two boosters on the right. All right, this will probably be the most useless amount of information you have ever been given in this class, which is a pretty bold statement. But here we have two of the nozzles, or caps, for the solid rocket boosters. We have the one in the picture on the left and the one in the picture on the right. The black stripe denotes the left solid rocket booster. And now you notice it in this image. This was actually a feature that was added after our first few flights of the shuttle program. All right, so the payload bay, this is where we put satellites. And as previously mentioned in the space station's beginning presentation, with Europe, we were going to put these space labs into the orbiter to conduct experiments, kind of like Skylab. So you have the external tank, the SRB, solid rocket boosters, the orbiter, main engines of the orbiter, and you have the same controls as a plane, your elevons. Little size comparison of the Soyuz capsule and the shuttle. Now, of course, for takeoff and landing, you're not in all this open space. You are in pretty confined quarters here, but it is much roomier than 3 people crammed into the Soyuz there. Kind of a sense of scale here. The 3 and a bit school buses, about the size of a shuttle orbiter. And just to throw out some more trivia for you to fill your head with, the Wright brothers' 1903 flyer at Kitty Hawk, North Carolina, flew less than the length of an orbiter. If you really wanted to sit and stare at all the specs, flight deck where the work is done, the space lab modules, main engines, greater detail cutaway. And just like the Apollo, Mercury, Gemini capsules, the astronauts would be laying on their back for takeoff. But instead of being atop of the controlled bomb, they're on the side of the controlled bomb. So major difference. Sleeping quarters, controls up here in the flight deck. We have the main engines, 3 of them, and then we have the orbital maneuvering system. So this is when you're in orbit, you can fire this thruster if you want to move to your right, fire this thruster if you want to move to the left, thanks to good old Newton's third law. So the OMS, orbital maneuvering system, these ohms. And when you mention the ohms, you often hear people talk about the RCS, the reaction control system. And that's located right here, this housing with the ohms there. And the orbiters are put together in the OPF, Orbiter Processing Facility. So right here. And those were located in California. So more specs. The external tank was brought to the Kennedy Space Center in Florida for launch through a barge method. Give you a little sense of scale. Some adult humans here, and the external tank being taken out from the barge. And then, of course, going to be taken to the vehicle assembly building. And it will be mated with the orbiter. So the solid rocket boosters are attached. And all the engines and motors. So here are your motors for the shuttle orbiter. First one's there. This one likely to go there. Sense of scale of these motors. You got an adult here. Then the orbiter is dropped down and mated with the SRBs and main tank. Any cargo or payload that's going to be put in space. Then you can see that Payload Bay mechanism. And then the crawler. A little bit later in the presentation, we'll look at some clips of the world's slowest moving vehicle, the crawler. And on page 16 of your notebook, you'll see the crawler down here. Obviously not to scale. And what's magnificent about the crawler is it carries, it transports, hence it's fully known as the crawler transporter. Little sense of scale. Here's an adult male. And here we have the mobile launch platform. You can see an adult here for size comparison. Pretty clever to take not only the vehicle, whether it's a Saturn V space shuttle, to the platform, take the launch pad as well with you. In your Alphamix appendix, the MLP, the mobile launch platform. So I'll look at the control center right there. And we'll show you some clips of the magnificent beast that the crawler transporter is. You also need to transport the orbiter to your Kennedy Space Center from the Orbiter Processing Facility in California. So they get mounted on top of a jumbo 747. Arrive at Kennedy Space Center. And very carefully put into the stacking facility in the vehicle right here. This is the dynamic test stand where they do a lot of vibration tests, make sure that it is suitable for flight, and then eventually be brought into the vehicle assembly building. You see a cap of a solid rocket booster. Hey, let's use that great knowledge you have. Is that the cap for the left solid rocket booster or the right solid rocket booster? Yes, for the left solid rocket booster. And here's the orbiter from the dynamics vibration tests, being mated with the external tank and solid rocket boosters. And then rolled out from the vehicle assembly building. And it doesn't take all day and all night to do this. This is a montage of different photos I've put together. And it's going to take you about 6 to 8 hours to reach this launch pad, traveling at about a mile per hour. And here's that long trip. You could walk there faster. Getting closer. Almost there. And meet up with your payload. And then the payload can be inserted. You don't insert it at the vehicle assembly building, just less weight, and so a little bit safer journey on the crawler transporter. And then it'll sit on the launch pad for several days. A great aerial shot here. And then side by side. This area right here is known as the White Room. This is where the ground control folks are going to work with the crew members and getting them into the vehicle safely and making sure that they stay clean. And so that emphasis on the term of the White Room and the white Tyvek suits that people will wear for keeping things dust free. Overview. And an actual overview shot. Stacked up, ready for launch. Oh, there I mentioned the White Room. And then, of course, the eventual liftoff. And we'll show you some launches as we look at the space transportation system, known as the Space Shuttle program. Now, most of that smoke that you're seeing here is really water vapor from the sound suppression system that tries to absorb a lot of that acoustic energy from those shock waves. The liftoff isn't straight up. It'll actually angle and arc over the ocean. I'll show you the times for these maneuvers to happen. So, of course, T-0 will be your liftoff. Just about 2 minutes into the flight, the solid rocket boosters will separate. And then about 8.5 minutes into the flight, you have MECO, the engine shutdown, or the main engine cutoff of MECO, and you're weightless. The ET is going to fall back to the Earth. It'll break up in the atmosphere over the ocean. And then you're orbiting. And one of the first things they're going to do is open the Payload Bay doors. And it's not so much because we're going to instantly get to work and launch our satellites, but you open up those Payload Bay doors to try and dissipate some of that heat that has been built up through that launch and reaching your main engine cutoff. So that you're aware, in your Alpha Mix appendix, we have the MECO, the main engine cutoff. So liftoff, remember it's not straight up, it's going to arc over the ocean. About 2 minutes into flight, your solid rocket boosters will fall away. About 8.5 minutes, the ET will fall away and break up in the atmosphere over the ocean. And then you're going to open your Payload Bay doors to let out that buildup of heat. The solid rocket boosters, something near and very dear to our hearts here in Utah, as the solid rocket boosters are made here in Utah. The rocket motor in particular at ATK Thiokol, and they're tested at Promontory Point. And here you can see a frame-by-frame shot here of the solid rocket booster separating at about the 2-minute mark. And this is what made the Space Shuttle so incredibly fantastic. It's reusable. So successful missions, this orbiter will be reused, as well as the solid rocket boosters. So they have chutes so that they can be recovered. And they have a vessel that is specifically designed to capture either the left or the right solid rocket booster. This happens to be the Liberty Star here. And you can get lost in all the details and the specs of the solid rocket boosters here. Highly encourage you to take a trip to the ATK Thiokol facility where they have a rocket garden. When your in-orbit mission is over, you're then going to re-enter the Earth's atmosphere, and the heat from the buildup of entering the atmosphere is going to be dissipated by this heat shield, the thermal protection system. And the vehicle lands like an airplane. Actually, more so, it lands like a glider because it's not powered by the engines as it is coming in for landing. It's a glider. Also, like a glider, it's a one-shot landing coming in at thousands of miles per hour. So let's look at this wonderful shuttle here. All right, the patch that goes with that picture is here in your notebook, and you might notice the CCP. If we go back and look at that image, you might see a blur of red. That's CCP and the Soviet Union flag there. What? This is often a trivia question you can win a few pennies from your friends with. The space shuttle for the Soviet program, they actually named it, the shuttle, they named Buran, B-U-R-A-N, Buran, which means snowstorm. And they also named the tank Energia, which was a snowflake, I believe. So a mission patch for the Buran mission. Here you can see the vehicle being built, stacked onto their Energia. You'll notice that they had 4 solid rocket boosters, so 2 on each side. Their solid rocket boosters were a little smaller, so having the 4. Here is the Shuttle Buran on the launch pad. We're ready for blast off on November of 1988. Buran, November 1988. So in your notebooks, you want to have the date and Buran. Soviet Shuttle Buran. Are you kidding me? They had a shuttle? Now, an important difference between theirs and the US is the fact that this was unmanned, completely remotely operated from Earth. So a test vehicle very much. No humans in there. Remotely operated. You see the Soviet flag here. And landing like a glider. Being guided in by MiG. And this is the first and only orbital launch of the Shuttle Buran. It was kind of a political thing. We know what you're doing. Look what we're doing as well. And here they are carrying it on top of a large cargo craft. And you can buy your own kit of Energia and Buran. Make your own model. Very sad is that after this one orbital flight, the Buran craft was pretty much left on the lay-by side of a road. And you could walk through it, this vehicle had been through space, so you could walk up these steps, just walk through it. Wasn't a whole lot to see, as it was just a vehicle remotely operated. These were mock-up of controls that if they had moved forward with manned shuttle flights, how the controls may have worked or appeared or fitted within the cockpit. And what's even sadder is it's just completely was been abandoned pretty much. And there was a storm a few years back that essentially just destroyed it. It's just sad that that was the ultimate fate of the Buran. Here's a schematic look at the Shuttle Buran. Well, side-by-side comparison, I kind of enjoy to think about that late 70s, early 80s, there's definitely espionage going on both sides of borders. I mean, look at these details. 23 8/10 of a meter, 23 9/10 of a meter, 26 meters, 24.5 meters, 56 meters, 58, 59 meters. And we were going to have a maximum of 8 crew members in the shuttle. Buran could, if they continued in development, up to 10. They claimed or touted that they would be able to have a payload of 100 tons. Ours maxed out at about 23 tons. What do you think? Which one do you like better? Hopefully out there the Patriots, the US shuttle there. So both nations did indeed have themselves a shuttle. Now, also in declassified information in the 90s, at the end of the Cold War, we discovered that the Soviets had been working on a large rocket, quite comparable to the Saturn V, their N1L3. And like I said, quite comparable to the Saturn V. You'll love this even more, that they had developed a lunar lander that might look vaguely familiar as well. Their Cosmos 434. Let's look at the American model of the space shuttle now. So when I was a kid, I always wanted to go to Orlando, Florida. Not to Orlando because I wanted to go to the Disney World, but I wanted to go to Kennedy Space Center. When I finally got to Kennedy Space Center, this is the moment my eyes first laid them on the vehicle assembly building. It wasn't too long after a hurricane had gone through, so you'll see these tiles missing. Give you a little bit of a sense of scale. A semi-truck could drive up of these stripes and not touch each other side by side. And at the vehicle assembly building, we've got to let you in on this awesome fact about these doors. Enjoy this clip.
Massive, powerful, and imposing, these are the tallest doors in the world. At the Kennedy Space Center in Florida, they protect spacecraft from extreme weather. They are the entrances to the vehicle assembly building, built in 1965 to house the Saturn V rocket that took us to the moon.
Their job is to keep all the elements that we have in here in and all the bad elements out.
Closing panel 1.
Roger that.
Del DeWeese and his team operate and maintain the equipment in the vehicle assembly building. The doors don't open and close without him.
We're going to open up the emergency egress in high bay 3 first, like we always do.
The VAB doors rise 456 feet, 1/3 higher than the Statue of Liberty and its pedestal. And they were built to a specific size. On its platform, the Saturn V rocket cleared the top by only 6 feet. With its fuel tanks, the Space Shuttle is only half the height of the Saturn V, but it's wider. There's only about a foot of clearance on either side.
The shuttle actually was designed around the buildings because it barely fits in here, and it barely goes in the high bay.
The vehicle assembly building is an open space, 52 stories tall. That space is divided up into 4 hangar bays, called high bays, and every bay has its own giant door. Each door, shaped like an upside-down letter T, is made up of separate panels that open and close together.
We have 4 horizontal doors that equal in width of like 150-some feet. And then you have 7 vertical doors that are above those that start at the 114-foot level, and then they go up to 456 feet. It takes approximately 10 minutes to open up the horizontal doors, and then it takes to open all the verticals, it takes 35 minutes.
In 2004, the doors protected 3 space shuttles by keeping out 3 of the worst hurricanes Florida has ever seen.
If we have a hurricane, the building's designed, including the doors, up to 125 miles an hour, and they've been through more than that.
Each set of doors weighs 888 tons. That's about the weight of 275 Hummers. They're made out of structural steel and covered in corrugated aluminum. The doors aren't computer controlled. They still rely on old-style push-button technology. The master controls are located 500 feet up.
Come on. Good morning, good morning. We're on the upper level, just under the ceiling of the vehicle assembly building. We're up at about 480, 90 feet. And first thing we do is we turn the breakers on, and we gotta let it go through this little cycle. We have to hit the master reset. And when we got all the lights, we got no bad lights, we're good to go. And then we have a warning horn, you should be able to hear that we have to operate.
When NASA built the giant doors, it assumed a 20-year lifespan and a maximum of 5,000 openings and closings. But they went 40 years without needing major repairs.
Coming down.
In 2003, NASA kicked off a 6-year restoration. When working on an individual panel, Del and the other technicians sometimes hop on for a ride.
You
First
know
time
your
you do
breezies
it's quite
want to.
exhilarating because it's got a 33-inch door you're standing on, nothing on either side of you. Then you have to hang out there over nothing and work on it.
Door panel number 3 is stopped.
Roger, I'm gonna get off. It's quite exhilarating, it is that. And not everyone in the shop will do it.
When the time comes for action, the doors frame an impressive spectacle. A giant spacecraft exiting the VAB and rolling down to the launch pad.
Ignition and liftoff of the Space Shuttle Discovery.
Without really seeing them, touching them, getting close to them, you don't really grasp what's going on, but it's really just something that you got to see it. I don't see how you can come close to it.
And then just outside the vehicle assembly building, you gotta love the stripes on the road here, outlined of the orbiter.